little thingy. Wait, is this still recording? Okay, so we're in your 99% Genius worksheet. So this is your homework for tonight. Homework Wednesday, 10/23. On each 2024. On each of the worksheets that will be homework, we're going to do a couple of them all together. Right? So let's look at number 2. Number 2, the problem says if 568 grams of HC2H3O2 can produce 408 grams of AlC2H3O23. Okay, right. So the first thing is just write down the information that they gave you. So 568 grams of HC2H3O2. All right, so I'm going to label 568 grams of acetic acid. Can produce 408 grams of this. All right, so 408 grams of this. This is a theoretical value. In theory, it can produce this. If 155 grams of the substance is actually produced, this is the experimental value. If 155 grams is actually produced, then what's the percent yield? Better. Okay. So, percent yield. The first thing we're doing is we're writing down the equation. Percent yield equals experimental divided by theoretical times 100. What was the experimental value from the problem? 155. What was the theoretical value? 408. Grams over grams, grams cancels. I multiply by 100 to turn it into a percent. Grab your calculator. 155 divided by 408 times 100 gives me, I gave you 3 significant figures in your data. 3 sig figs, 3 sig figs, 3 sig figs. How many significant figures should you give me in your answer? 3 significant figures. And the answer is 38.0% yield. 38.0% yield and box. Your answer.
So how do you tell which one is the theoretical and which one is the experimental?
When I read the problem, I saw that they gave me a value of a reactant and told me that it can produce. And so this can produce told me that this was my theoretical value from my train tracks.
So whatever number comes after can produce is the theoretical?
Right. And then it told me that if 155 grams is actually made. Right? So this actually made told me that came from an experiment. Okay, so question 1 and 2 look like this type of a problem where you just need to practice reading the problem and identifying what the numbers mean. Okay, but then if we look at 3, 4, and 5, they look a little bit different. So let's jump down to number 4. In number 4, I have potassium chlorate, KClO3, and it's decomposing to form potassium chloride and oxygen gas. What is the theoretical yield of KCl? So I'm looking for this. What is the theoretical yield of KCl in the above reaction if I start with 20 grams of KClO3? So can I calculate the percent yield yet? Do I have enough information? No. So the first thing I have to do is I have to calculate how much KCl can I make. Is the equation balanced as written? Yes. All right. So I don't have to do any balancing of the equation. So I start by writing down what I'm given. And I was given 20 grams of KClO3. And I want to find the theoretical yield of KCl. So, step 1. Before I can convert out of KCl, I have to convert from grams into moles. 1 mole of KClO3. 1 potassium, 1 chlorine, and 3 oxygens will give me the molar mass. And I already calculated it for you. The molar mass is 122.55. Grams cancels, leaving me in moles of KClO3. So this was the molar mass. Now I want to convert from KClO3 into KCl. Michaela, how am I going to convert from KClO3 into KCl? Where will I look? The mole ratio, perfect. And what is the mole ratio? 2 to 2. 2 moles KClO3 makes 2 moles of KCl. And this is the mole ratio. Moles of KClO3 cancels. I'm now in moles of KCl. And Caleb, am I done with the problem now? No? Why no? You got it. I need one more step. Grams of KCl. So 1 mole of KCl, I need to know how many grams of KCl. So this is the molar mass. This is molar mass of KCl, and I calculated that for you. It is 74.55 grams. All right. What did we just find? What do we call this value that we just calculated? The theoretical yield. So this is the theoretical yield. And all we need to do to calculate that is we have to multiply. Multiply, 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 multiply equals divide, divide, divide. So let's grab your calculator and let's make sure everyone can get this answer. All right, so 20 times 1 times 2 times 74.55 equals divided by 122.55 divided by 2 divided by 1. I gave you 3 sig figs in the beginning. I need 3 sig figs in the end. What do we got? 12.2. Very good. 12.2 grams of KCl. So this was a 2-part problem. So we did part 1. We have the theoretical yield, 12.2 grams of KCl. And then they wanted us to tell, so I'm going to box that, right, because this is 2 parts, so I don't want it to get lost in my work. Now the second part to the problem was what's the percent yield if 9.75 grams is actually produced, right? So they told me that 9.75 grams is actually produced. So percent yield equals experiment divided by theoretical times 100. My experiment, they gave me 9.75. Theoretical, I just calculated at 12.2. I multiply by 100. What happens to my grams label? Disappears, cancels off. 9.75 divided by 12.2 times 100. I gave you 3 sig figs. Your answer should have 3 sig figs.
Could we do like the same thing on 5?
Yeah. 9.75 divided by 12.2 times 100 gives me, Dylan, what'd you get? 80.0. 9.75 divided by 12.2. And I'm going to go times 100. Keep the 7, keep the 9, keep the 9. So I'm 79.9. 79.9% yield. Okay. And numbers 3 and 5 on the worksheet look just like this type of problem. Okay? All right. So, homework.